Okay, applications of variations. Notice the steps are listed for you. It says use the given information to write a function. Solve for the constant k. Use the function k and other information to solve the problem. So first of all, let's start by reading. The amount of chlorine needed varies directly. Remember, directly means multiply. As the size of the swimming pool. If 5 units of chlorine is the amount needed for 550 gallons of water, find the amount needed for 850 gallons of water. Okay, so first thing we need is we need to define our variables. So our first variable is going to be the amount of chlorine. I'm going to go ahead and call that C. That's the amount of chlorine. Okay, the other variable in the problem is going to be the size of the swimming pool. Okay, I'm going to go ahead and call that S. Now I'm going to go ahead and write the function. So it says C varies, and whenever I see varies, I think, okay, C is being compared to some other variable. So we're comparing, that means that C and S have a relationship. And so since I want to write an equation, that relationship is going to be equals. So when you see the word varies, we're going to write the word equals. It says directly, so that means multiply. So we're going to have our K times our S because it's a direct variation. K times S. Okay, now we plug in the information to solve for K, solve for the constant K. It says if 5 units of chlorine is the amount needed for 550 gallons of water. Okay, find the amount needed for 850 gallons of water. So in order to do this, we need to find out what our constant of variation is. So dividing both sides by 550, we get K equals 1 over 110 once I reduce this fraction. Okay, now going back to the original equation, plugging in our K value, we can now solve the problem. It says find the amount needed for 850 gallons of water. Okay, so we're going to plug 850 in for S. Obviously, we have a larger swimming pool here. And so we need approximately 7.727 units of water. I'm sorry, of chlorine. Right here, chlorine is measured in units, so we need to put our answer in units. Okay, looking at number 2. The time required to travel a given distance varies inversely as the speed of travel. So our two variables, time, speed. Inversely means to divide. Okay, T, the word varies, equals, divide, K always goes on top, over S. If a trip can be made in 3.6 hours at a speed of 70 kilometers per hour, how long will it take to make the same trip at 90 kilometers per hour? Okay, so let's plug in our information. Okay, time, 3.6 hours. Okay, speed, 70. So here, if I multiply both sides by 70, we have a constant of 252. Okay, using our original equation, T equals 252 over S. It says, how long will it take to make the same trip at 90 kilometers per hour? So we plug 90 in for our speed. And it will take us approximately 2.8 hours. Take a look at number 3. Go ahead and read it to yourself, please. Pause the video if you need to. All right. So we have power in watts. So power is going to be a variable. Varies, it's going to be our equal sign. Jointly, remember from our video notes, jointly is a product. So we're going to have a product, and product means to multiply. So jointly as the resistance, so we're going to need a variable for resistance, and the square of the current. So we're going to need a variable for our current. Power is P, resistance is R, current is C. So P equals, okay, jointly, so we're going to have K times R times C. And don't forget, it's the square of the current. So we have to square the current. For a 600 watt microwave oven, so power is in watts, so this represents power, that draws a current of 5 amps. Okay, so our current is 5. And the resistance is 24 ohms. So I'm going to plug 24 in for R. Now we need to find our constant. So we're going to solve this for K. And if you solve this for K, you get K equals 1. Now, using our same formula here, power equals our constant, which is 1, times the resistance, times the current squared. It says, what is the resistance of a 200 watt refrigerator that draws a current of 1.7 amps? Okay, plug the numbers in and solve for R. We have a resistance of 69.204 ohms. Resistance is in ohms. All right, last one, number 4. I tell you what, I want you to set up the equation for this. The equation is found in the first sentence here. Go ahead and set up the equation, and if you feel confident that you set that up correctly, go ahead and find out what is the intensity. What intensity would it register from 15 meters from the light source? Okay? So please give this one a try on your own. All right, we'll see you tomorrow.